Assalamualaikum and good day to everyone. Today we continue our new topic on simplification of force and couple system. The objective of the lecture today at number 1, you should be able to understand what is a single resultant. Number 2, you should be able to understand what is the moment resultant. And then number 3, you should be able to solve the problem by using a system of force and moment. Now we study what is equivalent system. Number 1, a force has the effect of both translating and rotating a body. And number 2, the extent of effect depends on how and where the force is applied. And number 3, it is possible to simplify a system of force and moment into a single resultant and moment acting at a specified point O. And number 4, a system of force and moment is equivalent to the single resultant force and moment acting at a specified point O. So this slide, you can see figure A. Figure A shows that the body is subjected to the force F at point A, and point O is on the line of action. Is equal to the figure B. So figure B, we can apply equal forces but opposite direction at point O. So we can slash negative F at point O and positive F at point A. So we just leave the force F at point O. So this figure B is equal to the figure C. So it shows that force F has been transmitted along its line of action from point A to point O. From point A to point O. So it shows that external effect remain unchanged after the force is moved, and internal effect depends on the location F. Like this slide, figure A show that the point O is not on the line of action of point F at point A. So this figure A is equal to figure B. Figure B show that the body is subjected to we apply equal force at point O here. Then we can slash the negative F point O at negative force at point O and positive F at point A. So we just leave the force at point O, and here we can define moment. So here we can have moment R cross F. So this figure B is equal to figure C. Figure C show that a couple moment is a free vector that can be applied at any point on the body. So here this slide show that the application of the effect of moving force. So this figure show that we have F1, F2 on the beam. So we can equal to the equivalence of force system. So here we have the force resultant. Force resultant is equal to summation all the forces here. So force resultant is equal to F1 plus F2. And then we also can have moment resultant. Moment resultant is equal to summation all the forces to the point A. To the point A here. So we have F1 times D1 and we have F2 times D2. So that is why we can have here moment resultant is equal to F1 D1 plus F2 D2. And then this slide show the effects of the person hand when the force is applied in the different point. So this figure show that the force F is applied at point A, and this figure show that the force F is applied at the point B, and this figure show that the F is applied vertical at point A, and then this one we show that this figure show that the force applied at point B. And here we can have the free moment, and so you can understand the difference between the effect of the force. Okay, why we need to study this one? Because when we have several force, so we can equate equivalent to this system. So we have the single force resultant, and then we have single moment resultant. Why? Because in designing of the IBIT, it will very helpful if you can replace the various forces and moment, just one force and one couple moment. So this slide show that when number of force and couple moments are acting on body, it is easier to understand. So this one, so this is equal to this figure. The two force and couple system are called equivalent system since they are have same external effect on the body. So here slide show that moving a force on its line of action. So this force and this force is in the line of action. And then this slide show that this force, and this force, okay, not in the line of action. So that is a change in the external effect. So now we can simplify any force and couple moment to a resultant force acting at point O and resultant couple moment. So this figure show that we can simplify into equation. So first we can have that resultant force. Okay, this is the resultant force is equal to summation all the forces. So summation force mean that summation force in X, summation force in Y, and summation force in Z. And then here moment resultant. Moment resultant is equal to summation of moment couple plus summation of moment about a point. So this slide show the simplification force and couple system. So this figure show that the system lies in a XY plane, which is 2D. So we can simplify into this equivalent system. So we have force single force resultant is equal to W1 plus W2 here. And then also we can have the moment resultant. So moment resultant we can have W1 plus D1 plus W2 D2. So here we can have the three scalar equation. These three scalar equation. So the first one you can have force resultant in X is equal to summation all force in X. So force resultant in Y is equal to summation all force in Y. So this is number 2. And then the number 3 is moment resultant. Moment resultant is equal to summation of moment couple plus summation of moment about a force at point O. So this is the summary. Procedure to use the following equation. This is the simplification of force system. So we have two steps here. Number 1, establish the coordinate axis with the origin located at point O. So number 2, force summation. Force summation first. If coplanar force system, we need to resolve into X and Y component. And then 2, if component is directed along the positive X and Y axis, so it say that it positive scalar. So if the component is directed negative X and Y, it represent negative. So in 3D, we need to represent forces into Cartesian. So this slide show the further simplification force and couple system. So this figure show the force acting on the plate. So can you identify the force in what axis? The force in what? Z axis. So this force, it can be equal to the equivalent force system. So we can have force resultant. So this force resultant is equal to summation all of the forces. For this case, the force is in z-axis. So this force at this point O. So here this force created the moment resultant. So this single force resultant is equal to this figure. So here, if we have force resultant at point P, so if we can have this distance, we can find the moment resultant, because we understood that moment is equal to force times distance. So this is if force resultant and moment resultant are perpendicular to each other, then the system can be further reduced to the single force resultant by simply moving force resultant from O to P. And then if three special cases, concurrent, coplanar and parallel system of force can be reduced to the single forces. Okay, now we move to the example. Let's do the example 4.19. So the question given, a 2D force system with the geometry shown determine the equivalent resultant force and couple moment acting at A, and then the equivalent single force location. So number one, so we need to find the force resultant. Okay, before we find the force resultant, we need to identify. So here we have the beam. This is the point A. So number one, the force already in vertical, right? So number two, is it the force is coplanar? So if coplanar, what should we do? So we need to resolve into Y and X. Okay, force 3. Okay, force 3 also coplanar. So we need to resolve into Y and X. Right, that is the number one. So number one, force resultant means that you need to get what is the summation force in X, and then what is the summation force in Y. Okay, number two, you need to get couple moment acting at A. So means that number two, you need to find and sum all the moment resulting from moving each force to the component A. So means that from here, so you need to resolve this number one force to this point A, and then this force also to the point A, and then this force also to the point A. So you should know lah, the into D moment is equal to force times distance. So this distance must perpendicular. Okay, number three, you need to find the distance D. So how to define the distance D? So the equation is given here. D is equal to moment resultant divided by FRY. So you need to divide lah. After you get the moment resultant A, divide by FRY. So let's solve. So this is the number one. Number one, you need to get this one lah. You already solved the summation force in Rx, and then number two, summation force Ry. Alright, so FRX, FRY. So how to determine the FRs here? Okay, so this is the FR. So this is the FRX, this is the FRY from here. This is Y. So the force resultant magnitude is 184 pound. So now this is the FR. Okay, the second one, we need to calculate the moment resultant at point A. So we need to resolve this point to the A. So that's why 200 times 3. This is the distance, right? Okay. And then another one is this one. This force 50 cos 30 times 9. 9 is this distance. Okay. And then the last force is this one. So this one go to there, become negative 100 times 4 over 5 times 6. 6 is this distance. So the final answer is 509.7 pound feet counterclockwise, because we assume that the moment at point A is counterclockwise. Okay, so number 1 settle, number 2 settle, and this is number 3. So number 3 is to determine the distance D. So this is the equation MRA over FRY. So this is the moment resultant and this is the force resultant in Y. So D is 3.12. Okay, so where is the D? So this is D. This is D. That we need to define D. Okay, understand? Okay. So we move to the next example. 4.20. So 4.20, the slab is subjected to 3 parallel forces. Determine the equivalent resultant force and couple moment at origin O. Also find the location XY of the single equivalent resultant force. So this is 3D case. Alright, number 1. Number 1, you need to find what is the force resultant. So we understood that a force resultant is summation all the force. So here we identify what is the force exit. So now we have F100. Okay, another one is 500 and another one is 400. So all the force lies in the Z axis. So we need to get what is the force resultant. So force resultant is equal to all the force in Z axis. Okay, number 2, we need to find what is the moment resultant. So for 3D, we have R cross F. So here we need to get this force already in Cartesian, right? Fk. So you need to get what is the R. Okay, from this force to this point, and then for this force to this point, for the force to this point, you need to get what is the R. Okay, and the third is the locations of the single equivalent resultant force. So from this equation, so for the X, so negative MRY, so moment resultant Y divided by the force resultant Z, and then Y is equal to moment resultant X divided by the FRZ. So we need to get number 1 first, and then we need to get number 2 before we can solve number 3. So this is number 1. So number 1, you can resolve. So we have summation force in Z. So here we have positive 100k minus 500k because of the force to downward, and then minus 400k also the force downward. So we can have here the force resultant is equal to negative 800k Newton. Then we can calculate the moment resultant. Okay, so you can have in metric form. Also, you can simplify like this, but you must beware. If you are use this technique, you should beware, because this 3i represent the R, right? So 3i cross 100k, this is the F. So you must remember I cross K. I cross K, we can get J. So here 3I cross 100, so it become negative 300J. Okay, plus here 4I cross negative 500K, she become positive 200J. And then 4J here, multiply negative 500K, is become negative 2000I. And then minus this one, 4J cross negative 400K is become negative 1600I. So this is the factor for the moment resultant. So after we determine the moment resultant, then we can determine what is the location. So for the X, we can have the negative moment Ry divided by FRZ. So we can have here, because of this negative, we put negative, so this one negative 1700 divided by negative 800, so we get the 2.13 meter for the X. And Y, we get the negative 300 600, negative 3600 divided by negative 800, so we can get the 4.5 meter. Right, so this is also this example 4.21 is the 2D force. So we have 2D force and couple system as shown. Determine the equivalent resultant force and couple moment acting at point A. So before that, okay, number one, we need to get what is the force resultant, right? So we identify number one here, force is in coplanar, so we need to resolve into X and Y. We need to resolve into component lah, X and Y. And then this force is already in vertical. And then number 3, this is also coplanar, so we need to resolve into Y and X. So what is this? Okay, this is the moment couple, because moment couple acting free position, so we just take the value 1500 Newton dot meter. So number one, so we need to determine force resultant. So force resultant, we can have sum of force in X and sum of force in Y. Summation force in X, summation force in Y. So this is the summation force in X and this is the summation force in Y. So we can find the magnitude of force resultant. So 1302 Newton, and here we can have the angle. So and then here we can have the moment resultant at this point A. So you need to resolve this point. Okay, this point to here. Okay, and then this point to here, and also consider this moment. So that is why we have 450 sine 60 times 2 because of the distance. Okay, and then we have this distance for this force 306 times 6 plus with the 700 and this one 700 cos 30 times ni, and then plus this one acting moment 1500. Okay, this one we assume the summation moment clockwise positive, so you can have summation moment anti-clockwise. You can solve by yourself this one. Okay, alright, the last example 4.22, force and couple moments are applied to the pipe. Determine the equivalent resultant force and couple moment at point O. So as usual, number one, we need to get what to determine the force resultant, we need to resolve summation of all the forces. So you need to identify F1 in what axis? F1 in Z. So F2 lies in what? F2 lies in X and Z. Okay, F3 lies in Y. So you need to determine this summation force. Okay, and then the second one, you need to determine the moment resultant. So moment resultant, we have here summation moment couple plus summation moment about a point. So for 3D, so we have R cross F. So here, this is the moment couple 1, this is the moment couple 2. But we need to identify what is the axis. So this one already in Z, and this one, moment couple here also in the I and K. Isn't it? Alright. So this is how we solve lah. So F1 is 300K, F2 here is 141.4I minus 141.4K, and then F3 here lies in 100J, and then we identify R1. So R1, this is the R1, because we need to create the moment R cross F. This is R1, and then R2, this is the R2, and then R3, this is the R3. This is the R3. So this is the couple moment, MC1. So MC1 already in K, and then MC2, I and K. So you can put into the matrix. So the first one is the force resultant. So force resultant, we have this one. This is for resultant. So we have 141I plus 100K plus 159K. And then to determine the moment resultant, we have like this. Summation moment couple plus summation R cross F. So here we have summation moment couple. Okay, summation moment couple is, this one is M1, this one is M2. So this is the R cross F. This one is R1, this one is R2, this one is R3. So after that, after you solve, you can determine this answer. Okay, that's all for today. Hopes you can achieve the outcome of the lecture. Number 1, you should be able to determine the force resultant. Number 2, you should be able to determine the moment resultant. See you for the next lecture. Bye.